Hey everybody, Dave Lindbergh in Hong Kong with another episode of THD Podcast. Today we have a gentleman joining us from the Bay Area who is has developed an operating system for earbuds, headphones, etc. So we're going to find out all about that. It's a company called Sonical, and so he'll be joining us in a moment. But let's not forget about the Alti Association, if I can point my finger in the right direction. Alti will be hosting a meeting suite at CES in the Venetian, level 3, Lido 3101B, something like this. Anyways, we'll put the information on the screen here. We encourage everybody to come check out Alti and find out what good things are going on in audio networking and the audio industry. So without delay, let's say hello. So Simon joining us from Japan. Good morning, Simon.
Morning, Gary, or afternoon, I guess.
All right.
Afternoon here. Nice to meet you.
All right. Thank you, Gary Spittle. Thank you for joining us, CEO of Sonical. How's it going over there today?
It's great. Yes, very well. Thank you. Looking forward to the Thanksgiving break, actually.
Okay. Very good. Very good. Yeah, we're gonna throw down on some turkey over here in Hong Kong as well. So that's good. We're looking forward to that. All right. So where shall we start? Let's maybe jump into a presentation and walk us through a bit of where Sonical comes from and what you guys are up to.
Sure. Yeah, I'd love to. Okay, so Sonical is all about developing an operating system for what we've called Headphone 3. So I'll tell you a little bit more about how we got there and what's inside it and what that enables product companies and software developers to do.
Mm-hmm.
So a little bit of history. I started off working in the professional audio a long time ago, and part of that work was about developing applications and software and hardware that were very compatible with each other. In fact, a lot of recording studios still use the equipment that I worked on many, many years ago.
Mm-hmm.
I then moved on to do quite a lot of consulting work, especially around putting operating systems into mobile phones. This was way back before Android was even a thing.
Oh,
And also working on music players.
I remember the Symbian that was on Nokia phones, right? And
That's right. Yes.
yeah, I remember that.
But it only worked on ARM processors for some reason. But we'll come back to that later. Then probably one of the most relevant pieces of work that I was involved in was the Bluetooth chips that CSR was making. And that became the number one platform for wireless audio. When we first started out, of course, there was no such thing as a Bluetooth headphone, and now they're absolutely everywhere. I also worked on some really low power processing, DSPs that could fit inside a MEMS microphone, and some really interesting Edge AI technology. But then more recently, I set up my own consulting company over here in California. And that gave us a really privileged insight into what headphone companies and hearing aid companies are really trying to do next. And that's really where Sonical was born. We realized that we had to create a new platform to enable this new technology to happen. So I guess the best way to kind of explain this is to think about what happened with smartphones when Apple launched this device that completely disrupted the old feature phone industry. And one of the key things about that device is it gave us access to apps. Now, I remember back when they launched it, I was thinking, well, I can't think of any apps that I needed. And that was fine because there were lots of very smart people out there that could think of apps and were developing apps and delivering them. And now, of course, I've got access to thousands of them if I need them. And what we found is that there's lots of other devices out there that they would really like to have access to apps too. But of course, getting apps from the phone into another device is actually really hard. So at the moment, apps tend to stop at the phone. But Apple recently invented something that's very interesting called CarPlay. And if you've ever used it, what this enables you to do is it takes your phone into a car, and now everything that's in my phone appears on the car screen. I can use all of my music applications. I can use my navigation applications, and it's a very personalized experience. And the car manufacturers love this because no longer do they have to try and integrate all these apps themselves and try and figure out what all their hundreds of thousands of customers want. They simply just turn up with their phone and they just support CarPlay or Android Auto. And this also gives developers another channel of where they can focus their application development. So we were looking at this and we were thinking, well, what if this happened next? What if all of a sudden there was something called earplay, where I can take my phone and I can connect it to some earbuds, and now all these apps are pushed into the earbud? Maybe this would be really helpful. And so we started thinking about this in some depth. And that's really where this whole concept of an operating system for your ear came about. So we took that concept to a whole bunch of headphone companies, loads and loads of people that we knew in the industry, and we shared it with them and said, would you be interested in having access to these kinds of applications? And the very interesting response we got back was, it's not that they all wanted the same app and we could just build that app and then we're done. They actually all wanted very different things. And so the range and combinations of these applications made it absolutely clear there wasn't going to be a one size fits all. So we then went hunting for some of the application developers that could actually create these new features and asked them, why aren't you putting your technology into all of these headphones? And we got all of the usual responses. It takes too long. The chips are difficult to work with. Integrating with everybody's applications is really hard work. And so they basically told us they needed an operating system, something like the Android experience, where you build it once and it kind of works everywhere. And we thought, well, that sounds like a really good model. But then we basically ended up with the need for an ear computer. And so we've been developing this now for the last nearly 3 years to really enable the industry to make this shift from a fixed function, limited product into something that's completely user-driven. So how did we get to headphone 3? Well, to get there, you have to start with headphone 1. Headphone 1 was really, back in the sort of 1970s, 1980s, when the Sony Walkman came along, and now headphones became really popular, and they were wired devices, and they basically just squirt sounds in your ears. But people really liked that experience of taking music on the go. Then we know what happened next. CSR created this fantastic Bluetooth chip with a DSP, and now headphones became really interesting. Not only were they wireless, they could be customized, and each manufacturer could tune them really easily to create different sounds and add new features. But it did come with a lot of limitations. And so what we've noticed recently is one company in particular has decided they're not going to play this game anymore. They're going to create their own system. They've got their own processors, their own software. They've got obviously a great connection to their own phones, and they're just crushing the market with all of this new technology. And all the other guys are really struggling to keep up because they keep trying to fight with these Bluetooth processors that were never designed for this. And so what we've done is really place headphone 3 as the next obvious step. If you think about all the other devices that we use every day, our laptops, our phones, and our smartwatches, they've all become user-driven, where we go and get the apps that we want after we buy the product. And that's what we're doing for your ears. So to enable this to happen, we built CosmOS, which is our operating system. And what we have running right now is the ability to take applications that are on a cloud-based app store, whether that's with Apple or Google, and we can download these apps to a phone. But then the app doesn't stop there. We take that app, and then we can then deliver any combinations of those features directly to your headphone. So that's what we've built, and that's what we're going into production with that next year.
So just to dumb it down for people, perhaps, especially myself, it's really like, this really solves one of the major issues about porting these things. So sometimes people say we want to implement, say, the Mimi technology onto their headphones, and then they have to make sure the processor is compatible and figure out how to port that application onto the headphone if they want to do it as a standalone feature. But with the OS approach to things, you're basically putting a platform that people could insert any envelope of an application onto. So it kind of standardizes things. So it makes it easy to load new applications. So that's kind of where this is all heading. Is that a good summary?
Yeah, that's exactly it. So if you liken it to the Android model, if I build an app for Android, it will work everywhere. I don't need to know what chip's inside the phone or the smartwatch. I don't need to know how much memory it's got. My app is going to work. I may get slightly different performance depending on the capabilities, but Android makes it really easy. And so we're trying to do the same thing here with your ears so that I can go and get an app, and it doesn't matter what chip is inside that device. We're going to do our best to just make it work. Now, there will be some customizations for each individual type of acoustics and so on and different capabilities, but the concept is exactly that.
Okay.
So if you think about the chips that are out there, it's pretty obvious why this hasn't already happened, especially if you look at the performance of chips in, say, your laptop today or your phone, or even here, a very prominent gaming console. You see how the performance of the chips has really improved. But if you look at what's been happening with the chips in our headphones, they've barely changed at all. And it's because they've been focusing on a fixed set of features, and they don't really need to do much else. And instead, there's a lot of focus on just reducing cost and size and power consumption. But what we really need is a new type of processor, something that's very efficient and small, but that can handle multiple applications running at the same time. And the second piece, which has also been holding us back, is the connectivity. So again, all the devices that we're currently using have had amazing improvements in connectivity, but Bluetooth hasn't really changed much. And again, the standard use cases of a Headphone 2 product are absolutely fine. I can listen to music, I get really good quality, and I can make phone calls. But if I want to step beyond that and do something a little bit more different, then I need a bigger pipe. I need something that can download applications while I'm listening to music or on a phone call. I want to get lots of data in and out of my earbuds. So we need better connectivity as well, and we're already partnering with many connectivity companies to enable that to happen. So there's three main areas that we're focusing on for this Headphone 3 platform. The first is the obvious one, which is listening to audio. So there's a lot of improvements that could be done just for listening to music. We could make it spatial, like Apple have been doing recently. We could make it a much higher quality or even lossless with higher data rates. We could make it multi-channel. So all of these things become possible when you don't limit yourself to what Bluetooth supports. But the next area is slightly more interesting, which is about listening to the world. So how do we combine this with the ability to intelligently control the noise around us and feel safe when we're outside? And how do we deal with wind? A lot of these headsets today, the ANC doesn't work so well if you're outside in windy conditions. And so listening to the world is actually something that's not just important for people with hearing loss, it's actually beneficial for all of us if we have the right software. But by far the most interesting thing that's been happening with our platform is about listening to your body. So we can now put together sensors that can gather all this information from inside your ear and start telling you things about your health and your wellness and whether you should be exercising more or you should be doing things differently. But what's happened even very recently is combinations of these. So the ability to use sensors in your ear to monitor your vital signs combined with listening to music, for example. So the music might be intended to help you relax. Well, we can actually measure that now. We can see what impact that has on your body. Mm-hmm. And if you can measure something, then you can do something about it and improve on it. So we get these very personalized experiences now, all possible with this Headphone 3 architecture. So the way the system actually works, and I put together this very simple animation because doing a live demo doesn't quite come across on a video. We're able to download apps to a phone or a tablet. And inside these apps are what we call plugins. And plugins are basically just the library of code that is going to work on CosmOS. And what the user does is they select the combination of apps they need for their particular use case. Let's say I'm about to get on a conference call and I need a particular combination of apps to deal with that scenario. And I just download them to my headphones. These are apps that were not in my headphone when I bought it. They weren't, introduced by the manufacturer. These are just things that I need to use with the headphone that I currently own, and I go and download them. And then I can change it. After I finish my conference call, I might go outside for a walk with my dog, and I'll have a different combination of apps for that activity, and I can just keep changing it all day long. The other interesting thing that we've seen happening is people are thinking about new types of product concepts. And one here that we can share is something like a TWS Pro version where we've got intelligence not just in the earbuds, but also in the charging case. The charging case, in our opinion, has been this missed opportunity to add some more processing, some intelligence, maybe a touch screen. And it's a great place to have all your apps handy in a really simple user interface, so you don't have to keep finding your phone. So this new concept, is really going to unlock some very interesting new features.
I think just something that a lot of people have been focused on lately is getting people to leave their phone at home for a while to have some mental relief. There's a lot of discussion on the well-being of people stuck to their screens all day. And I think that kind of product where you're not totally separated, but it's kind of like, weaning people off of their phones is almost like a solution with the case. Yeah,
I think so. And I think it's going to introduce some new ways of using these devices as well. So if we...
Just something I wanted to just touch on so that I'm not sure if you're going to come up to this, but what kind of processing power are people going to need if they want to load your OS onto their products? Is there kind of a standard spec that you might spit out to people?
Right, I can cover some of that. So the sort of under the hood of a Headphone 3 system is a slightly different product architecture. And it's no real different to what's inside your laptop or your phone. You have a host processor and then an operating system, and then all the peripheral components that you need to make that device. So that could include Bluetooth, or it might actually include other radios. We're working with all different types of radios. There'll obviously be some kind of audio input and output, maybe with noise cancelling. There could be some co-processors in there. So all of these things are still needed. But the host processor, there are going to be some chips that just do not support what we're developing. They just won't have the horsepower, and they're not intended for that. They're intended for more of the sort of mainstream low-cost devices. But there are some really good host processors that are about to come onto the market that we're already partnering with companies for. And these are chips that have significantly more processing inside them. So they could easily run, 300 or 400 MIPS of processing. They may have 1, 2, or even 3 megabytes of RAM. They'll have lots of I/O on them. But even those chips, with our first initial customers, we've already filled them up. Because of the number of applications that it will be running, it's very quick to get to a point where the user can't add any more features. And so that's why we're also developing our processor. Because we've had this insight into what people need, we've got a really good understanding of the kinds of processing that needs to be put onto the next generation silicon. And we're partnering with companies to make that happen as well.
Okay, excellent.
And so you're working on a processor kind of as a necessity? I mean, the key element is the OS, or is it both?
The first step is to get the OS deployed onto as many chips as we can, and that's already happening. But because we've seen such an appetite for even more advanced processing, we're developing the silicon as well. So it's a bit like, back in the old days when you had your personal computer. Every 2 or 3 years, you'd have to go and get a new one because the apps have just filled it up and slowed it down. The software keeps improving. So then you go and get one with a faster processor and a bigger disk drive, and then it feels like it's fast again. The same thing's going to happen with our ears. The algorithms that people have developed, especially around machine learning, are really big. And we need to have processors that can cope with that and not drain the battery in 20 minutes.
And so taking the case of a Bluetooth headphone, then would it be the situation that the current Bluetooth functionality remains as is and the Sonical OS runs on a separate core, for example?
That's right. Yep. So we would run our OS on a separate chip or on a separate core within one of those existing chips. And that would enable people to get access to maybe 2 or 3 apps or 4 apps at a time running simultaneously. But if they wanted to go beyond that, they would need an upgrade to a more powerful processor. And, it's a bit like when you buy your phone, you say, I want this much memory in it and I want this kind of processor. Then I say whether I want cellular connectivity or just Wi-Fi. We see that same thing happening where the manufacturers can really just focus on the capabilities and sell that rather than selling features and trying to predict what the customer wants. Let the customer decide that piece.
Okay.
So the way the system works, basically there's two main components. There's a processor with an operating system, and that gives us access to hundreds of apps. And we're spending a lot of time assisting people to get onto the platform. We'll also be able to connect in lots of sensors. So it's been very difficult for people to work with some of the existing chips simply because, again, they were never designed to support this. So it's no surprise it's a challenge. So we're building that in from the very beginning to enable these to happen. I've already mentioned that we're going to need new types of connectivity, and a lot of the early adopters that we're working with are going to be using multiple radios. They will have Bluetooth for most of its applications, but then it will switch to something else if it needs to have that additional bandwidth or additional improvements in performance. And what that will enable us to do, of course, is use the device for longer periods of time. So it won't just be, if I'm just listening to music when I'm on the train, I could use this thing all day long because it might be monitoring my health for me. It might be helping me do other things and helping me relax. It might be helping me sleep. So there's now a much broader range of applications that could be used because we've turned it into a computer rather than simply an extension of a Bluetooth link.
Mm-hmm.
Okay, so that's kind of the story.
All right.
So, building an app, what does it look like? What kind of development environment are you working with, and things like that? Is it
so all of our apps are actually developed in C, and because it's cross-platform, we can take these models that people have created, this code, and we make it work on chips that have maybe an ARM inside them, or a Hi-Fi, or a RISC-V core. It's all completely compatible.
Yep. And it's compiled code?
When we download it, it's all compiled code.
Yeah,
so
okay.
It's obviously secure as well. We want to protect people's algorithms, so everything's encrypted.
Interesting. And so do you have to produce a development environment to go with it, or are you using off-the-shelf tools?
It's a little both. So we didn't try to reinvent the wheel here. There's some really good IDEs out there and development tools. But we package all of that up with our hardware development kit that then people can then start developing their apps really quickly.
Interesting stuff. And what kind of you touched briefly on the kind of apps that people are building or interested in. Could you say a little bit more about that? So, for example, a heart rate monitor. How do you know if the headphone has a heart rate sensor in it or not? It's kind of thing.
Yeah, so there's a little bit of handshaking between the app when it's still on your phone before it gets pushed into the headphone. So we asked the headphone, do you have all the capabilities needed to run this app? Because it might not. I mean, that's a good example. If it hasn't got a heart rate sensor, there's no point putting the app in there.
Right.
So we do have that handshaking to say, are you at least compatible with the device? And if it is, then the device can load it and start using it.
Yeah, there was some guys we interviewed from Montreal that are trying to figure out how to measure the voltage signal to the transducer to get a feedback loop, so you don't actually need a PPG sensor to do heart rate or
that must be a tiny signal.
Yeah, I don't know. It's a real delicate measurement. And given kind of your background, like doing the edge AI processing, so this would all be considered edge processing as well once it's loaded onto the earbuds?
Yeah. Okay. Yeah. And of course, we support all kinds of AI algorithms. A lot of the software partners we're working with, they develop these pretty huge neural networks. And they have the similar pain point of they have to take that network and then make it work on all of these different AI accelerators. And each one's completely different. So they end up with 15 sets of code and all this customer support. So we're trying to consolidate that as well.
Okay. And the edge processing creates a benefit for some brand customers that I've experienced where they see that it prevents cloud sharing of the data. So basically edge, it's kind of an endpoint. And so there's nothing going to a cloud from that edge processing. So your data is not being shared. Is this something that's a benefit to you? And then part two of that question is, are there some issues that you're approaching with your architecture to avoid any privacy issues with EU, especially, and also US?
Yes, but only early days. So we're very early in terms of getting hold of personal data from the ear. But we're working with the medical companies that are experts in that to create that ecosystem. But you're right. What people don't want, and this was new to us, is they don't want to have their device permanently tethered to their phone and all of their data just passing through and then going into the cloud. What they do want is some kind of intelligence on the device itself, and then only pass on information that's relevant. So it's almost like there's a gatekeeper in the device they buy, and then only essential information is passed on. But even then, that's why people are building intelligence into the charging pod, which is owned by the device manufacturer, to avoid having to go via the phone. So we're seeing like a completely closed off ecosystem of devices to prevent that data sharing happening.
Right. Yeah, I can see a benefit to that, because I know in the smart speaker space, some companies, especially in Japan, were interested in having an edge wake-up processor and not sharing to, like, whether, I don't know the Japan versions, but not in Amazon. They didn't want all that data flooding into Amazon when anybody said, if it's always listening type of application. So they wanted that edge kind of wall there.
Mm-hmm. Yep.
And one other thing I was kind of curious about in just preparing for this is, like, so we can establish that hearing devices is kind of your leverage to get started in this. But do you see this parlaying into, like, so it's probably go to hearing aids? Yes, that's kind of obvious. But are there other products that you can see, like this concept of an OS going onto many other devices in the future, IoT, security systems, stuff like this?
Yes, and some of the companies we work with, they already build other products, not just headphones. So there's obviously audio things. We could put this into smart speakers, professional microphones. We could have intelligence and algorithms in, broadcast and podcast applications. But there's also the stuff that goes beyond that. If it's just considered a data handling system, then it could go into medical devices. It might go into devices in my house. Security systems is a very good one. We had one guy who wanted to build a device to deploy onto his brother-in-law's farm. Not quite sure what he wanted it for, but yeah, people are really thinking very broad about this, because all of a sudden their device has access to a lot of apps, and they can just download these apps to the product and turn it into something completely new.
Yeah, no, I mean, the smartphone, like you said at the beginning, it was revolutionary, and it just becomes a platform like your computer is. You can just load whatever you need on there.
The difficult part of it is we're trying to do it without a screen,
right.
which is really tough.
And yeah, I can see that the user might get befuddled. Like the average user might be a little confused. So maybe the smart case, or the case with the screen on it to help in the early days, might be a measurement against returns, because there's nothing worse. I can't figure it out, and the American
just send it back.
Yeah, you don't want that. And so
that's a key point, though, isn't it? Because it's actually based apps or functionalities that are not based around the user interface. Is that it's behaviors that you want to happen autonomously for the most part.
Autonomously or intelligently, yeah. We expect them to be at a point where they can understand what's going on and what the user is intending. But the very first devices are all going to be very, very user-driven. They will use their phone, they will select what they want, and then that combination gets downloaded. The intelligence will probably come later.
Yep.
Okay. And then deploying your own processor chip is a big undertaking. And this is going to be a fabless development? Are you working with some original building blocks already in place to help make it
Yes. Oh, absolutely. Yeah, it's 90% off the shelf. But there's a critical piece to it that is needed for all of these types of applications to work, and it also means that the operating system will also be more efficient. So yes, we're not intending to reinvent processors or interfaces or special types of memory. We've already worked with a design house to get those building blocks in place. We have added a lot of our own secret sauce in the actual architecture of the chip, because we know what it's going to get used for. But it's really about the difference between building a chip that's very application specific or building a chip that's an open platform as a computer. And one of the challenges about building a computer is you don't know what someone's going to use it for. And that's basically what we're trying to do.
Yeah. I remember an engineer told me probably 15 years ago, it's a miracle that Microsoft works at all with, and then fast forward Android, trying to run all these different like hardware platforms and running everybody's idea of an application on it. It's a big undertaking. So yeah, kudos to your initiative here. It sounds exciting, and I can see like a lot of applications for this. I mean, looking at the list of software suppliers that you've been partnering with, we've spoken to quite a few of them on this podcast, and trying to get it ported onto the hardware was usually one of the challenges. Which Bluetooth chip are you using? And so this way people have a clean kind of understanding if it's compatible. So that's great. Anything else you'd like to ask, Simon?
I think, what's the model? How do you think this will work commercially?
So we'll be licensing our OS to product companies, so they will put this onto their selected processor, which we've given them guidance for to go into their product. And then there's a licensing model for developers as well. So if they want to get access to the OS that's in all of the new products that are coming onto the market, then there's a license fee and obviously the development kits that go along with that.
Okay. And will people generating apps be selling those in a marketplace, do you think? Or is it going to be dominated by people who are providing the apps kind of free to go along with their devices?
We're seeing a whole mix, actually. I think there will be a lot of free apps that you'll just get in the product when you buy it, which is fine. But there's also some of the premium apps where they either want to still license those to the headphone company, and maybe it appears on the company's website or on the phone app, and they can pick and choose from a selection. Or it's something that they can just go and have downloaded by the user directly. So they'd like to have that direct-to-consumer channel as well.
Awesome.
All right. So yeah, Gary Spittle, thank you for coming on today. Any closing remarks, Gary, before we say goodbye?
Only that this is a really exciting transition. Thanks for inviting me on so I can share our story with people. And we're looking forward to seeing this thing take off.
Okay. All right. So everybody we'll put all kind of links in the description below so you can follow up with some more information to get in contact and more details on the Sonical CosmOS operating system. So once again, thanks, Gary, for joining us today. And everybody, like, subscribe, share, all that good stuff. And we'll see you next time.
Thanks very much.
Bye-bye.